All right, RwLocks. Very quickly on this one because I am running over time. RwLock is built right into the standard library. There's a C++ equivalent. It has the option to call .read to get you a read lock and .write to get you a write lock. And you can have as many readers as you want, exclusive or one writer. So it's just like the mutable variable system. Now it sounds fantastic. I just wanted to give you a quick word of warning that obtaining a read lock is actually slower than locking an uncontested mutex. So only use this if you've got a case where lots of readers and an occasional writer. It's also easier to accidentally deadlock by because when you go into write mode, that writer has to wait for every reader to finish. So you have to make absolutely sure that your readers do finish. You're not holding a read lock forever just so you can peek in. It often sounds like you can do that. It doesn't work that way. From my bitter experience, use read write lock with care, and don't even try read write lock until you are absolutely comfortable with mutexes. So leave that for your really advanced code where performance is a problem. Most of the time you will just find you don't need it. So pretend it doesn't exist until then. Okay, so thinking back, when you looked at that mutex, why, since we're sharing it, being mutated, we're not ever declaring, let mut my mutex. We're always saying let my mutex. And the reason for that is it's called interior mutability, and it implements what's called the sync trait. Sync is one of the few traits in Rust that is added for you. If everything inside your structure implements sync, then your structure does too. But that's kind of a hand-wavy answer. So what that means in practice is sync is only implemented by things like mutex, read-write lock, atomics that handle synchronization between threads on your behalf. Or you can write some one line of unsafe code, shout YOLO, and declare that my structure is safe to synchronize. Only do that if you know what you're doing. So I'm not even going to show you how to do it, but YOLO unsafe is a thing. I recommend, rather than shouting you only live once, you think very carefully before you do that. But there's a lot of benefits to being able to use interior mutability in the same way that mutex does in your own code. So first of all, you can hide some complexity from your users. If you're writing a library in particular and other parts of your company or other people are going to be using it, it might be nice to decide at some point that you want to replace your mutex with something else. Or you might just not want to have all your users have to remember to lock a mutex just to call a function. So instead, you can put the mutex in the structure. So we have structure, my complex thing, data, mutex, and a string. So it's not very complicated at all. I lied to you. And the mutex is sync. There's nothing else in the structure. So your structure is now sync. And this has the nice thing that okay, when we make it, we have to put the mutex inside. Most of the time you'd use a constructor, hide that away. And we can reach in, lock it, push string, but you notice this is in the implementation. And so when we use my complex thing, we just call do something. You'll notice it's and self, not and mut self. So it's perfectly safe to share it between as many threads as you want. You won't get borrow checker issues. It handles its own locking. And as such, nicely isolates the complexity out. Your users don't even have to know that there's a mutex in there. They simply never run into problems when they start using it between threads. You can improve concurrency too. It's pretty common to have a threaded program where different threads operate on different parts of the same data. So if you want to, you can make my multi-part thing. Now we've got data mutex, string, data 2, data 3. Please don't use the names data, data 2, data 3. Use something that actually means something, but it seemed like a decent choice for a webinar. This way, when you write functions, they can lock just the part they need, so they won't be serializing access to the other parts that they don't need. Streamlines your program. You still only need to be exposing and self as opposed to and mut self. So the borrow checker won't give you a headache, won't give you a hard time. You can simplify your program quite a bit by doing this, hide the complexity, make for happier users, because the happiest of users are the ones who don't necessarily know how the sausage is made, but always get the right answer.